Hi, in this podcast we are going to continue our objective of reviewing the practice unit exam on chemical bonding in hopes to correct for misunderstandings. Question number 7 reads, which type of chemical bond is formed between two atoms of bromine? Let's take a look. What is bromine? Bromine is right here. Let me see if I can point to it right here. This is bromine. Now, if you have any doubts, Br, atomic number 35, we could always go to table S, not that version of it, right here, table S. Look for atomic number 35. Atomic number 35, there she is, bromine. Okay, so now we know we have the right thing. Get this out of the way. And let's get this out of the way. So what was bromine? Bromine is a non-metal. So two atoms of a non-metal, when bound together, well, what do we get? Bromine is a non-metal. When a non-metal is bound to another non-metal, with the electronegativities being so high, they're going to share electrons. The definition of a bond that shares electrons is covalent bond. A common misconception for students that took this exam was they chose ionic bond. Remember, please, an ionic bond means we have two ions that are going to be bound together. And for that to happen, there are three circumstances. We could have a metal bound to a non-metal. We could have let's get that out of the way. We could have a metal bound to a polyatomic ion, or we could have a polyatomic ion bound to a non-metal. All of those circumstances would result in an ionic bond. Question 8. What is represented by the dots in the Lewis electron dot diagram of an atom of an element in period 2 of the periodic table? Well, let's go ahead and take a look at period 2 of the periodic table. Yes, period 2 of the periodic table. Period 2. Here are the periods. Period 2 go across, all the way across. And what are we actually looking for in order to build the Lewis dot diagram? Let's take a closer look. We are looking at right here. 2, 1. We're looking for the 1. Beryllium, 2, 2. We're looking for the 2. Now, how do we define that second number? That's called the valence electrons. Well, let's expand on this. What if we were going to go down the group? Well, the last shell is 1. Last shell is 1. Last shell is 1. Group 2. The last shell is 2. Last shell is 2. In any event, the question is actually a lot simpler than it first reads. Again, let's take a look at it. It says, what is represented by the dots in the Lewis dot diagram of an atom of an element in period 2 of the periodic table? I'm going to cross a little bit of it out because some of it does not matter. In all honesty, I don't care that it is in period 2. Any Lewis dot diagram is always talking about the valence shell no matter where it is on the periodic table. And for that, we are looking at question 3. Sorry, choice 3. Question 9. Base your answer to the following question on the information below. Now let me tell you, this question, as all of them are old Regents questions. This question probably had many follow-up questions to it. Let's go ahead and read. A metal designated as M, was obtained from a compound in a rock sample. Experiments have determined that the element is a member of group 2 on the periodic table of elements. Now it says, explain in terms of electrons. In terms of electrons. You must mention electrons in your answer. So, explain in terms of electrons why element M is a good conductor of electricity. Now it's a metal. Most people mention it's a metal, but they did not talk about the electrons. Here's the answer that I would give. The electrons of any metal are highly mobile and are therefore free to move, resulting in an electrical current. All right. It could have been phrased in many different ways, but you have to mention that the electrons are mobile. That alone would have given the answer. Question 10. Given the key, here we have one atom of oxygen, that's the open circle, and the closed circle is an atom of carbon. You are to identify which particle diagram represents a sample containing the compound CO. Now that's carbon monoxide. One carbon, one oxygen. Once you recognize that it is one carbon and one oxygen per compound, number 1 could not be a choice. 3 could not be a choice. And in closer inspection, 2 could also not be a choice. Now why? Because in number 2, that is 2 atoms of oxygen, no carbon at all represented. Now a common misconception with this one was number 1. Most people looking at that could recall that we did have CO2 that looked like this, and therefore your particle diagram that looks like this looked familiar to you. But you had to recall, or you had to inspect just what the question asked for. It said CO. Therefore, the answer is and can only be choice 4. Question 11. Which formula represents a molecular substance? Now, whenever you see the word molecular, you must think of covalent bonds. Therefore, we're looking at sharing electrons, and we're looking for a non-metal bound to a non-metal. Inspecting these, we have lithium and oxygen. Let's take a look at the periodic table. Is lithium a metal or a non-metal? Well, there it is. Lithium is a metal. Oxygen, a non-metal. Choice 3 is an ionic bond. Next, aluminum. Aluminum is right here, and oxygen. Metal and non-metal, once again. Ionic bond. Calcium and oxygen. Calcium is right here. It's a metal, and oxygen, a non-metal. It too cannot be the choice, but we need to confirm. Let's take a look at the last one. We have carbon and oxygen, both nonmetals. High electronegativities need to share their electrons. It must be choice 2. But another test-taking strategy you could employ. Well, couldn't you say one of these things is not like the other? One of these things does not belong? Where choice 1, 3, and 4 all had metals bonding with nonmetals. Therefore, they were like substances. 2 would then stand out as a very probable choice. Now we find ourselves question 12. Question 12 asks you to draw a correct Lewis dot structure for each of the following. We're going to look to draw an atom of hydrogen, one hydrogen, an atom of nitrogen, one nitrogen, and then a molecule of ammonia, which is NH3. Let's inspect our periodic table, looking for our valence shells. Hydrogen has a valence of 1. There it is. While nitrogen has a valence of 5. So each of those individual dot diagrams will have the valence shells represented. Let's get this out of the way. Grab ourselves a pen. We'll do A. Hydrogen had 1 valence shell, 1 valence electron. B. Nitrogen had 5. Those are correct for A and B. But when we make an entire molecule of NH3, it looks like this. Here's our hydrogen, our nitrogen, hydrogen, hydrogen. I'll put X's for the valence electrons that come from hydrogen. Those are the 3 from the hydrogens. From the nitrogen, remember there were 5. 1, 2, 3, 4, 5. There it is. And this brings us to question 13. This will be the last one of this installment. Go on to part 3 for the balance, going up to 18. This question reads, which electron dot formula represents a substance that contains a non-polar covalent bond? Right off the bat, quick inspection. I notice with number 1, I see ions being represented. That would have to be an ionic bond. It cannot be choice 1. Now 2, 3, and 4 are all shown as covalent compounds. They are showing electrons being shared between the elements. So now we need to do one of 2 things. Let me do the most simple and the safest, and that's inspect table S to look at the electronegativities. Chlorine has an electronegativity of, let's find it. Here's chlorine, 3.2, hydrogen, 2.2, and oxygen, 3.4. So let's remember that. 3.2, in fact, let me write these down. So 3.2 for the chlorine, hydrogen had 2.2, and oxygen had 3.4. Now I could get this out of the way. Okay, now we look at the electronegativity differences. Well, chlorine versus chlorine, 3.2 minus 3.2. We have an electronegativity difference of 0. We'll do this one over here. Chlorine at 3.2 versus 2.2, an electronegativity difference of 1.0. And then we have oxygen and hydrogen. Oxygen is 3.4, while hydrogen is 2.2, an electronegativity difference of 1.2. Our answer is going to be the one that has the electronegativity difference of 0. But let's stretch this. What if the question asks which one would show the most polarity of the covalent bonds? That would then be here. But if it also asked which one has the most polar bonds altogether, well, that's the ionic bond to begin with. Let's go on to part 3 for the balance.